Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop. I thought I'd throw in a gratuitous photo of my Allen Mogul 7.5-inch gauge live steam locomotive. It's kind of cool comparing the two. This is the whistle, the steam whistle on the Allen Mogul, and here's the steam dome with the two safeties on here. And I just kind of show that for comparison, because the project we're working on now, if you've been following along, is the 3.5-inch gauge LBSC Tich. This is the book, what the book looks like, and it's been quite an interesting project making this little Tich. In this week's episode, we'll cover the steam dome, and I'll pull this off, show you. There's the safety, the single safety that's on top. I bought that from Blackgates Engineering. And I'll show how I machined and modified the steam dome so it fits on there nicely. We'll also talk about the piping for the water pump. There's 3 lines that go to it. One is to the right clack here. There's also, I'll walk around over here, there's a supply line that comes from the bottom of the right tank. And then there's a bypass valve line that goes here from the back of the pump over to the bypass valve over here. So in this episode, we'll cover machining all of those things and how it all fits together on the locomotive. I think it'll be very helpful for somebody that's building one of these things, because the book honestly does not talk in much detail about how to run those lines. So hopefully me showing you might be very helpful. We're getting very close to finishing the project, and the next thing, I was almost going to do a wrap-up video here, but I'm going to do one more because there's something I want to do with the ash pan underneath. So we'll cover that and any other final last-minute things on the next episode. So thanks a lot for being part of the journey. I appreciate y'all being along with me on this. Ask any questions that you might have. If you would, please give me a thumbs up even if you don't have any questions, because it does help. It motivates me to keep going with the project. And I hope you enjoy, and we'll look forward to hearing what you have to say. Thanks, everybody. Well, the last casting that I need to machine for the Tich is the steam dome, and I just set the pressure valve in place. It's not screwed down or anything, obviously, but you can see that it is higher than the inside of the bell of the dome. Let me put it in place, and you can see. There's no way I'm going to make it just as they call for in the plans. What I am thinking about, and I'll give this some thought, but I could machine the dome and the saddle and everything, and then open up the top of it so the relief valve is actually basically flush with the top of the dome. That would make adjusting the valve easier. I know the stock look is to have 2 little tubes coming out of here, but I think that I like the practicality of having the access to the relief valve, so I may go that route. My Allen Mogul, that's how it is. I'll walk over and show you. I keep it covered up, keep dust and stuff off of it, but we've got 2 relief valves on here, and as you can see, they just stick out of the top. I got a nice hold down there that was a brass acorn that I turned, but that's a nice look, and it's very practical. For planing the whistle and the mount part will be easy enough because there's a space underneath the running board here. Clearly I have removed the right hand tank. You can see the holes, the mounting holes, and I just kind of laid the whistle out in the spot where it'll be, where it won't interfere with any of the workings of the gears down here. So it'll be up underneath the running board there, and I'll have to fabricate the mounts for it. And I also needed to figure out the piping connection, because if I was to use just the copper tubing, to make the bends without kinking, they'd have to be long looping bends, and it would interfere with the steps here, and it would be tricky to say the least. So what I've planned now, I can still use this copper tube from the whistle valve, and I'll cut a notch in the running board here, and this will be just long enough, and I can use a couple of these small PM Research angle fittings. You can buy these in little trees, casting trees, and you can see I've already cut a few of the fittings off of this. I can cut this elbow fitting off and machine it as an adapter. Basically, I'll put this one here, have the pipe, the copper tube, come into the top of it, have a short piece of tubing to connect these two, and then this one can be machined so that the whistle can screw into it. I think that's the plan that I'm going to use. So this should be an interesting kind of fun. I love doing the piping. I love machining these little PM Research fittings. And if you missed any of my other videos with making the valves and such, I've made a little jig. I've got these for all different sizes for the PM Research. This is a globe valve inside here. It's a fixture that will hold it steady while I do the machining, and this will also work for the T and the elbow fittings too. So I'll be using that, and I will show you this process here. It should be kind of cool and kind of fun. Started to work on the connections for the whistle, and here's the little 1/4-inch elbows. This is an unmachined one that I've cut off the tree and sanded the edges smooth. This is another one that I've marked the centers of, and I went ahead and drilled and tapped this one out for the 1/4x40, so use a number 5 drill. This is the 5/32 drill that will be used for the rest of the passageways, for the because I'll just silver solder the steam connections in those sides. Very well, then this is the first one done. I've just drilled it through with the 5/32 hole, so you can see how much smaller that'll be, but that'll be perfect for silver soldering to the tubes now to do the other one. This was a fun night. Got to make the elbow. This is the first elbow that we made that had the 1/4x40 thread on it. It's threaded onto the whistle. Here's the other one that just has the 5/32 holes in it. It's connected to the steam pipe that will come off of the whistle valve like this. I just got it kind of mocked up. Naturally, I'll have to shorten this tube some, but you get the idea. It'll be connected up there, then down below, coming down below the running board, and then connected with a short piece of 5/32 copper tube between these two holes. That'll be silver soldered together, so it'll be like one assembly, and then the whistle can just screw into that. But we won't make this all final until we make the mounting straps and cut the little notch in the running board. I'm going to do that tomorrow. I'll cut the mounting straps and mount the whistle, and then we'll cut the notch, and we'll have our final fitment for everything, and we can silver solder up the fittings. Next up is making the clamps for the whistle. First thing I did was mock up a little cardboard version. You can see it kind of looks like an Adel clamp, and I was thinking that would be fine, but I realized I really want the whistle to be a little bit lower, and I also want to provide some clearance for getting for the screw. So I think I'm going to make this design sort of a G-shaped design. Let me see, there you go. So the whistle will be clamped in the part where my thumb is down there, and then it has this longer attachment arm. I'll put a little hole in there, and that's where that'll be. And happily, I have some of that door bumper material left. This is about 40 thou thick brass, and one of them has a hole right in the right place. So I think I'm going to go ahead and clean this thing up, cut it and bend it, and try to use that for my clamps. Here's the first of the whistle clamps, and this one came out pretty good. I kind of out-tricked myself though. I used a 3/8 inch rod to curve this around, and I really should have used something bigger, because as you can see how oblong it is, I had to widen it with some pliers. This stuff, when you start bending it up, even though it's only 40 thou thick, it's really pretty stiff. So what I'm going to do for the second one, here's the blank, I'm going to bend it. I found a drill that's about the exact outside diameter of the whistle, so I'll use that, and I'll show you the technique is just to put it in the vise, clamp it there, and then bend it first by hand and gently by tapping it with a hammer, and then I put the final bend on the 3-in-1 machine. So I'll show you a little bit of that. Here's what I mean. I've got it clamped. I just bent it over by hand. I haven't used any hammering. Now I'll loosen it in the vise and I'll rotate it a little bit and do it again until I'm almost done with the bend. And here's the one that I made around the drill bit so you can get an idea how I made it. And now I'll go over, I've got that line that's a 3/4 of an inch in from the end, that's marked, and I'll put the 90-degree bend in it there. And then there'll still be some massaging, tightening and stuff to go with the vice grips, but that's pretty good shape for what we need. Here are the clamps set up. Obviously I've got the thing removed and inverted, so here's the tube that comes down. It's roughly in the right place. I have yet to put the notch in the running board here. I'll do that, but first I want to drill and tap these holes so we can get the exact right position, and I will have to crimp these tube holders a little bit, but I think that's going to be good, and it'll keep the whistle clear of the rotating parts, the valve gear and stuff you can see right there. Here's the whistle mocked up in place on the little brackets, and as you can see, one thing I was trying to do is to make sure that the little air slots for the whistle were clear. So we've accomplished that. We've got the whistle piping in a good line there, and we're also clear of all the motion gear here. So I think this is a success. What I need to do now is to cut the notch, which is, happily, I think it's going to be right where I marked it. So I'll cut the notch in the running board so that pipe can fit through, make that nice and neat and pretty. And then when all is said and done, we'll get the final length for the trimming and silver soldering of the pipe. And I can silver solder all those connections together down below here. Here's the supply line just mocked up. I've shortened this tube here, sanded it down in preparation for soldering, and I had measured this tube here, so this is just snugged up finger tight on there. But now I can put the running board in place and see if it'll fit to that fitting, and I can take the fittings off and solder them all together. Well, every video is better with a little fire in it. This is my little insect repellent candle, which I use to light my mini torch, which I have set up here. I really do like using this thing, and I silver soldered the ends together in the proper orientation, hopefully the proper distances. That's, you can see the magic marker on there. And now we'll let it cool a little bit. I did anneal this tube also, so I'll let it cool a little bit, put it into the pickle, and we'll do a final test fit. I couldn't be more pleased. So this is I just mocked it up to see if everything fits like I hoped it would. Take this off, rotate this around. You can see, basically to screw this in place, I needed to it already was, but just unscrew the whole whistle assembly from the running board. That way I could thread it onto the nozzle here and the union, and it's all fitting nicely in place, and so thrilled that it lines up real good here too, so I think I'm going to be in good shape. Next thing I'm going to work on is the steam dome. That's the only piece that I haven't machined so far, so I'm going to work on the steam dome, and after that we will do the piping. I think the final piping that will go with the from the water pump to the water tanks. Okay, I'm prepared to machine the steam dome. Thought I'd start by setting it up and in a way that the outside is pretty uniform, and then I can machine the inside to fit my brass adapter. So I've got the little interrapid half thou indicator here, and I've got it. This is about as close as I can get. Of course, you know, we're measuring off a casting, so it's like plus or minus 10 thou either side, which I think for a rough casting that's unmachined is pretty good and pretty uniform. Okay, I think this should be the last pass. Just going in 1/4 of an inch. And the whole goal is to get this to widen out to 1 1/4 inches inside. I've been miking it. I'll show you that in a second. So far, so good. Here's the countdown on the DRO. 200 thou. Just moving it by hand since my automatic feed is broken. Coming up on a 1/4 inch here. A little bit more for good measure, about 265 thou. Back it out slowly. This bodes well because it's holding nice and solid. That was my main concern, or that little stub holds solid enough to machine it. Okay, there we go. Clear it out. Turn the lathe off. So you can see it's not even completely machined on the inside. Part of that is wider than 1 1/4 inch already. But now I'll mic it and I'll test fit it with the little piece of brass. I'll bring you back and show you that. Here I mic'd it and I'm about 6 thou shy, and I also tested it. Here's the hunk of brass that I plan to machine to put inside there to make the little adapter, and it doesn't fit either. So double checking myself, I'll take another pass, a little spring pass at about 5 or 6. I'll go ahead and make it 6 thou, and we'll see if we can get it all the way widened out. Alright, so let me show you the fit here. Really pleased. I ended up taking like 2 spring passes just very carefully, and as you can see, it's funny, I just took it out, it slipped right in, but it's not too loose, that's for sure. There we go. So that thing fits in there nice. It won't be this thick. I need to machine this down, basically just make it into a thick washer with a 1/2 inch hole in the center. But I'm really pleased. That fit is perfect. So now I can just leave that be and start working on the outside. And I think I'm just going to use files to try to remove the finish, get the finish as smooth as I can. Not make it perfect, because ultimately we're going to have to cut the top nubbin off there and then drill a 1/2 inch hole. I'm not quite sure how I'm going to do that. I may end up putting it in the 3-jaw, with a large 3-jaw to do that. So we'll just try to clean this up a little bit now. That's just after a couple of minutes of filing with the lathe running at 220 RPM, and I've been mostly using this kind of rough to me, half round file, 1/4 round, whatever you want to call it. I really like that. I use this full round one a little bit on the root edge here, and then this great big huge old worn out big file just for general smoothing, and I've got a couple of fine ones for when I get it a little bit smoother. And then, once that's done, I can just start with the sandpaper. Here's the steam dome after I've used the files, and then I used some 60 grit sandpaper, and then some 150 grit, and then I used the Dremel, used a couple of these non-woven abrasive heads on it. They come in something like 280 and then 3 something grit. I used both of those in the Dremel tool while rotating the lathe by hand at first, and then for the final few passes I've had it under power at 220 RPM, and I'd just run the lathe and run the Dremel. The worst part is, on my casting anyway, was right in here. There were some little voids and pits and things. You can kind of see where I've sanded them out. I guess I'll work on this just a wee bit more, but I am pleased because I was able to get rid of all of the major pits that are most noticeable. But this thing will be very visible. Let me show you. Here's my selection of stuff. Oh yeah, I used this kind of a flapping wheel first. That was very effective after I got done with the regular sandpaper. And I used some of these individual sanding drums to try to get rid of more of the pits, and then I blended with these abrasive bonnet kind of things. Really like these things that Dremel makes. Very effective and helpful. It saves hours of hand sanding on a project like this. So I think as soon as I get the finish like I want it, the next thing to do will be to start drilling successively, and I'm going to drill up to a 9/16 inch hole in there and so there'll be a little room around the top of the pressure valve. So we'll see how that goes. That'll probably be sufficient to disengage. I won't have to cut it off because I think 9/16 is probably about the distance of the little stub there. And that's as far as I got drilling, and now I'll have to cut what's left of the end off. You can see the finish is pretty decent all the way up to the top. So I'll cut what's left of the end off, and then I'll just have to figure out a way to grasp this, maybe put the big 3-jaw on and some tape to protect the finish, and then finish drill that out to 9/16. I'll bring you back for that last process. And here's the steam dome with the end cut off on the bandsaw there. The only thing good about it, I got really happy with that finish, and you can see inside the little ledge I made to hold the spacer that'll hold it on to the actual part of the locomotive. So now I've got the big 3-jaw back on the lathe, and I've got some 16 thou thick brass shim pieces there to protect it and clamp it in. So I'll put that in and finish drilling it out. Alright, here's the semi-finished dome, just test fitting it over the actual steam pressure relief valve. So there's a little slop. That's a little bit bigger of a hole than I was actually trying to get. I kind of needed to do that because of the size of the stub, but that's perfectly fine with me. It doesn't hurt anything. I think it's still going to look great, from a side view or from a distance. It'll look like it was supposed to be made that way, which it kind of is, in my opinion. So very pleased with that. And tomorrow night I'll come back and machine the inner portion so that it fits snugly around this part right here. Alright, here's basically the finished product. I'm really happy with how this came out so far. Naturally I'll need to polish the steam dome up to a high polish eventually, but for now this is good. And nice clearance all around, very symmetrical there. And so here you can see I've got the brass insert inside and setting down, and it fits on this part right here, this 3/4 inch diameter part. So I think that's going to be great. I may massage the bottom part of it a little bit so when I get closer to final fitment, but very rattle free basically, and really pleased with how that came out. I did realize one thing after I test fitted this thing, and I'm glad I didn't fasten it in there. I needed to account for the screw heads. I didn't want to use flat heads. I like little button heads, so I made a little notch, kind of a upside down wedding cake notch in the spacer to allow for the bolt heads. Well, to clear the screw heads, I ended up milling slots there. I should have done that in the first place, but as you can see now I've got it to fit. It sets on there. There's a little bit of wiggle there. I've got the front marked, and I've also recessed around the bottom of the steam dome there to clear the brass bands, because they'll be in about that position anyway. So what I'm going to do, I will put some screws in here, but just to fix everything in place now that I've got it all fitted correctly, I've marked the front there. I'm going to put a little green Loctite around there just to hold it together, and then I can let it dry overnight and put some screws in. Now that the steam dome is settled in place here, the next thing I need to do is to do the piping for the axle pump. It's even hard to see here, although you can see. Let me put a little spotlight on it. There's the axle pump here, and as you can see, this line here is the forward line that goes up to the right hand clack, and that's the only one I really need to have the boiler in place for this process. So let me walk you around the other side here. I had pre-bent this thing when I first made it, so I've got it, and now basically all I really need to do is bend it out and then up and then cut it off and then solder on the cone fitting for it and make sure I've got the nut in place. So I put the right hand clack in place with a washer to orient it, and it's all snug. So I'll be working on that, and like I said, once this one's made and fabricated and in position, then I can take it off, and then I can take the boiler out, and then that it'll be easy to access. I'll have the right hand tank in place, so the supply line that goes to the bottom of the axle pump comes out of the right hand tank, and then the bypass line comes into this fitting right here, so it'll be better to have the boiler removed to be easier to feed everything in place that way. Here's the line from the front of the pump that hopefully will go to the right clack. It's kind of a bunch of twists and turns there, but I did remember to put the nut on first, and I got the little cone silver soldered, and as you can maybe tell, I did heat the entire body of it there to give it a little flexibility for the fitment. So now just let it air cool for a few seconds, then wrap a wire around it and put it in the pickle for a few. Clean that off, and then we'll try to get a final fit. Probably doesn't look like much, but it's, to me, looks very good. Here is the front line to the right front clack, so it's coming out of the water pump there. Oh, it's a lot of glare. So you can see the shiny copper line here that I'm playing the light on. So let me walk around here, and we can see I've got the line connected. Really thrilled that there was a lot of twists and turns, like I said, kind of a lot of spaghetti, but it works, it connects, it's tight on both sides, so I'm pleased about that. I'll take that off now, and then I can remove the boiler. I'll have to loosen this fitting here and the whistle fitting, but I'll take those off, and then we can remove the boiler, and it'll make it a lot easier to do the remaining connections to the pump that just go into the right tank. To show the setup here, I've machined the little street elbow for the water fitting, and I did make a little conical indentation there in the bottom for the cone to fit in, and then I've just threaded this. I've used my lathe, my tailstock die holder, to thread the 1/4x40 on the bottom of the L, and I've also tapped it 1/4x40 so it can adapt to the tank there. Here's the look of the tube that'll take us from the bottom, this is the supply line, bottom of the axle pump, up to the little L that I just made on the water tank. And now I just soldered it, so we'll put it in the pickle. Okay, here's the line installed. Here's the little street L. I put a spacer in there. It's pretty thick to give it that perfect angle, and because we're not dealing with pipe threads here. And then I've got the conical section here, and the 1/4x40 nut, and the pipe that comes around, curly Q into the bottom over here, the bottom of the pump. So let me slide this in here. Hopefully you can see some of it underneath there. There we go. Nice. I set the boiler back in place to make sure that the clearance is okay for the little elbow fitting that I made. Hopefully that's showing up. And there's the line that goes down to supply water to the pump. And yes, the clearance is okay. The other reason I put this here is I wanted to see how much room, because I've got to run the line from the back of the axle pump here. This is the line for the bypass valve, and as you can see, there's a whole heck of a lot of stuff in the way. You wouldn't want to have it go underneath the ash pan, and there's not a lot of room in between the frame rails and the boiler, and there's no hole, convenient hole anyway, to run it outside the frame rails. So what I did, I took this piece of brass rod here. I'm thinking that the most logical solution will be to run, this is an 1/8 inch brass rod, and there's clearance there, it runs into stuff, but you can see it here. Well, I can see it anyway. So I think that's what I'm going to do, is run the pipe for the bypass valve along the side of the boiler above the frame rails, and then bring it out over here. And here's my first take on a possible solution for the bypass valve wire. This is just a hunk of soft solder that I had. I cut it off and I've got it, see a little sweeping S-turn here and go underneath the elbow and then straight along and then back underneath behind the steam valve for the whistle and up to the blower valve right here, or the bypass valve. Not sure how all these bends will work out exactly, but that would give me a fairly smooth path. So one thing I'm definitely going to have to do is to I've got the soft solder cut. I'm going to put in some bends like I would from my little bending jig. And we'll check that. The radiuses that I can get with this bending jig. I've showed this before with the 1/8 inch tubing. And once we have that for sure figured out, then I can actually anneal this tube and put the bends in. I definitely want to anneal it first because that's a lot of bending, so we'll see. Alright, I think I've worked out about the best solution possible for the bypass valve line. So I'll mark it and cut it off here and then silver solder on the little cone. Make sure I put the nut on first. But as you can see, the line comes down here, it goes inside the whistle, the steam line for the whistle, and along the frame rail, on the top of the frame rails, inside the tank area there, and then underneath the elbow, the street elbow that we soldered or we fastened to that fixture, and then bends down and comes out the back outlet of the tank itself. So you can get a good view on the front line that goes up to the clack. So it looks, I think, like I said, it's about the best solution I can come up with. I sure hope it works okay. Okay, here's the line with the cone and the copper cone and the nut in place, and of course the other side I'd already done months ago. You can tell by the coloring here, I did anneal this pipe with the torch while I had it on, just to give it a little extra bendiness for the final installation. So let it air cool for a little bit, and we'll put it in the tank, clean it up, and this will be done. Oh, I know the reason I wanted to show the picture is just showing a way to kind of chalk up the line, the irregularly shaped line, while you're heating it. I have these little scrap pieces from when I was working on the superheater. I saved them and they're handy for putting things into position like that. Alright, quick recap. I'm going to put the boiler back on in just a minute to make sure everything fits. I'm pretty sure it will since it fit before, but as you can see, I've got the front line out of the axle pump. This goes to the right hand clack. I have the supply line that comes from the right hand tank, and I bolted the tank down, just to make sure everything fits just right. You can see the line goes here to supply the axle pump at the bottom, and then I've got the 1/8 inch copper bypass valve line that runs along, goes up behind the little elbow, and inside where the boiler is adjacent to the tank, inside the steam line that supplies the whistle, and then up to the bypass valve here. So pretty satisfied with how everything fits together. Can't wait to put the boiler on in a second and see what the fit looks like. Alright, here's the boiler back in place. I did have to make one modification. It's going to be hard to see, but I trimmed where the steel comes down. This was interfering with my line and the bypass valve line, so I cut it off about this level on the opposite side, and I've got it taped down just to keep it out of the way. And I did have to do a little finagling to get that to fit in there. It was a little bit of a squeeze, but it fits nice and solid with the little lugs against the frame. I think the lug on the opposite side is actually rubbing against the line, so I'm going to file that down when I take it out again. I'll make a note to do that. I don't know if you can see that in there, but it's a kind of a tight squeeze. Still quite adequate, and very happy with all the fittings. And I didn't realize it, but I got a lot of stuff in this video, so I think I'm going to make this the last segment for this week's episode. I still have some more detail work to do specifically on the ash pan, and I'll probably do a separate episode about that. So anyway, thank you for watching. Please ask any questions that you might have. Please give me a thumbs up, and I'll make any comments you might like. Again, I appreciate all the participation from the audience and appreciate being along for the ride. Thank you.